if somebody made a satellite that would circle the Earth really fast, then somebody can buy a ticket, get on there, for 3 days, come back, and 50 years passed on Earth.
But my question is
Yeah,
that
but
if you
the travel more than the speed of light, not more than, equal to speed of light.
No, so this is a very common question. I feel like the most common question I get from people that, they haven't studied physics is like, can we go faster than the speed of light? And there's even some friends that have told me like, oh, that's just us right now, that we haven't really done we don't have the technology yet, but one day we'll go past the speed of light. So this is like a fundamental fact of the special theory of relativity. And it's not even that the speed of light is special. It's just that there is some max velocity. And let me tell you why. If you do the math behind special relativity, you can find that there is, you can calculate your velocity through space-time. So how fast you're going through space and time. And that has a constant value, a constant magnitude. You can only travel, you cannot change how fast you move through space-time. Now, what special relativity said is, okay, if you move faster through space, then you must move slower through time. And if you move faster through time, you must move slower through space. But the sum of these two, or the magnitude of these two values that you have, velocities, is always going to be the same. You can only exchange them. So there is just a constant velocity through space-time. And that is what gives as a consequence all of these phenomena like time dilation. And so if it weren't true that there is a limit, we wouldn't see these effects, which we have already proven. So we know there is a limit. Now, there are loopholes. The thing is,
Tachyons can go faster than light.
Cations? Well,
Tachyons.
Yes. But I can't remember what I ran on them. There's different types of cations. But I don't know if any of them has been like experimentally proven. I don't think so. But so there are other loopholes. That Einstein's theory said you can't move through space-time faster than the speed of light. But Einstein's theory of general relativity says that you can warp space-time and that you can move space-time or expand it or contract it. And there's this physicist, Alcubierre, he's from Mexico, that designed a specific shape that you can put shape space-time, that if you get on the middle, space is being expanded on the back and it's being contracted on the front, and whatever's in the middle would travel. So you can essentially move faster than the speed of light without moving through space-time, because you're moving space-time with yourself.
With you, yeah.
So it's kind of like a loophole.
Is that Alcubierre drive, I guess?
Yes.
Yeah.
I don't know many of the details of that, again, because that's also general relativity, which I don't know too much about. But because I don't even know what would happen, like what would someone outside see? What would their clock look like? Would there be any time dilation? I don't know. I don't know how that works. But there are loopholes that make you travel faster than light with respect to other people without traveling through space-time faster than light.
You move the space-time through that thing.
Yeah. So with
it.
Yeah. So with the current methods of transportation we have, we can't move faster than light. Like if you had a car that you can accelerate and accelerate and accelerate and accelerate, you could never pass the speed of light with respect to someone else.
Right.
We would need some new way of traveling.
Can nuclear energy be used for that?
Can nuclear energy be used for that? Is that what you said?
Yes. Can be nuclear energy used to generate that much of power so that we can traveling with that?
So when Alcubierre first developed his drive, he even said this is nonsense. There's no way to warp space and time this way. Since then, I think it was NASA that put some money into it, and they developed a different type of space-time distribution. So it's not the Alcubierre drive, but it's the same concept. It's just a different shape, and it doesn't require the crazy energy. I think it was, what was it, a 25%, 75? It was much less energy than what the Alcubierre drive needed. So they're slowly bringing it down, and they're better ideas now. I don't know how they would create that energy. There's also the issue that one of the sides, I think, needed negative energy, which
Okay.
I don't know if the NASA research fixed that. I haven't read that, but that was also something we like today, till this day, we don't know if that exists, because that would be the same as having like negative matter. Like if you had two planets that repelled each other instead of like
Right.
pulled each other. So we think that doesn't exist. There's no evidence in the universe that exists at this point. So that was another complication with the Alcubierre drive.
So my basically doubt is that if we travel with the speed of light, what would actually happen? The time will stop with respect to Earth. I'm talking about the.
Yeah, so that's a great question. And Einstein said this question is a nonsensical question.
Exactly.
Because you cannot travel at the speed of light. An observer cannot travel at the speed of light. So the question of what would happen is nothing would happen, because it's impossible. And there are no physics for what would happen there. But if you think of light, a light particle travels at the speed of light. Light does not experience time, and they do not experience space.
Nah, right.
Okay.
Take that as however you want. We don't know what that means.
But light is not an observer. How can it observe space and time?
Exactly. It doesn't really mean anything.
Right.
But we know it can't, because it travels at the speed of light.
So do you think time travel might be possible in any time future?
Well, I don't know if soon. Well, like we know, there was a website that already tracked how much astronauts have time travel, because they spend time on the space station.
Right.
Which, so when they come back, they're like a few microseconds younger. And there was a cool website that tracked how much younger they were from people on Earth. I have been.
That's 0.005 seconds, I guess. I read that
-6. So we're already kind of time traveling. It's just not as exciting. But
that classic time machine, which we see in movies, that we sit on it, or like something that we
it can be like
kind
that.
of teleport to a different time.
It would be like that. The thing is that it would have to move. Like if you sit on it, and then in the movies they start shaking, and depends on the movie.
And they travel to the different time.
Yeah. So it would need to start moving. It needs to go somewhere and come back, and that would work. Or go in an orbit. Doesn't matter. But it has to be in motion. But yes, it would look exactly like that. And we just have to, it would require a lot of energy. And right now, the more energy we use, the more we affect the planet. So I don't think in the near future that would be a thing.
But it's kind of a bait. If we manage to do that, then we can open more. We can open many doors of more possibilities.
I mean, the only thing you would be able to do is travel into the future. You can't travel into the past.
Why?
Right, because the clocks are always ticking. It's just you choose which one ticks faster, but you can't make it tick backwards.
That cannot be possible.
Yeah, the theories do not prohibit backward time travel, but they don't. There's no way of how to do it. They only show time dilation, which is forward time travel. We think that backwards time travel is impossible because there's a lot of paradoxes that would happen, but it's not
grandfather paradox.
Yeah, it's not proven through physics. Through the equations of physics, they don't prohibit it.
So that might be reason we have never seen a time traveler in our time, because they might be going to future and they can't come in past.
Yeah.